exercise. So review and exercise for Unit 2. Okay, first of all, first topic, identify variables, units for the rates. So this whole section is about the rates and how things change. There are different way for things to change. One is according to linear model, one is according to the exponential model. Maybe we have some other models that is not linear and not exponential either. So now, first, any model has input variable and output variable because we use models to simulate the real world events. So we have to have input and output to be a model. So in this first exercise, we want to be able to identify what is a independent variable, what is a dependent variable. Independent variable is also called the input variable, and the output variable is also called dependent variable. Actually, it makes sense because the output is always depend on the input, so output is dependent. And in terms of graph, the horizontal axis represents the input, and the vertical axis represents the output. So as a variable in the first problem, variable is not the units. Okay, a variable is like a holder that can hold values. In this case, our variable is time. Input variable is time. And this time is measured in years this time. It could be measured in seconds, hours, right? It's just a different units, but the variable itself is time. So it's a time. Use either time or time in years. Either way is okay. Depend on what option in that multiple drop-down options you have, answers you have, drop-down list. So time in years, apparently output as from a y-axis is a value in dollar. You can also say dollar because this case, any value is measured by monetary units. In this country, by default is dollar. So output is value in dollar. So that's your input output variables, independent and dependent variable. Just make sure you know horizontal represent independent variable. That means you provide value to it and then you calculate the output. So output depends on what you give it as input. Okay, second one. Now this time we have different curve. And whenever you read a graph, always read the meaning of these two axes. Otherwise, this curve, no matter what shapes it has, doesn't make any meaning because you don't know what this curve represents. So again, this time horizontal input variable or independent variable is time in years, but output variable is Fox population. Its population basically is whole number. You can say population number. So input is time in terms of years. Even if you don't have year, it's still correct. Okay, the variable itself is time. It is measured in year. Dependent variable is population. You can say Fox population. And that's it. That's the answers. So this just exercises to make sure everybody can identify the dependent variable and independent variable. Now let's look at this one. The population of a town, which is represented by Y variable in X years. So X represents time in years, can be found using the following model. So if we have this model, they ask us what is the initial value in this model. Now, in this course, we only learn two different types of models. One is called the linear model, one is called exponential model. You need to be able to differentiate or be able to identify which model is which. And to help you recall that, I put this on the side. This is a two general form of these two models. First, linear model. It goes like this: Pn, this output, equals P0, which is the initial value, plus D, which is called a common difference, which is also the growth rate. In terms of graph, it is also equal to the slope of the line, and times the input represented by N. And N is input, Pn is output. Any model has input and output. And keep in mind that input and output are just two different variables. You can use totally two different letters, which result in the same meaning. Again, this is just a representation, can be any letter. But in this book, we use Pn as output and as input. Otherwise, if you use yi as output, you just replace Pn as y. And if you use x as input, replace it with x. This whole thing will never change, still stay the same, the meaning. So this is initial value and growth rate. This is linear model format. Now exponential model. And output equals initial value times 1 plus growth rate, could be positive, could be negative. If this R is a negative percentage, that means it's declining. If it is positive, it's increasing. To the power of N, say input, output. If this is Y, this is X. So now apparently, if you compare the two models, which one is closer to our problem? Apparently this one. Even though we have 1 plus Z, but it's just a percentage. When you add them together, it will become one number. So initial value times a number raised to the power of input. This is exactly the same. So this is the exponential model. Apparently, this P0 is this number, which is called initial value. So initial value is 25,000. Since this output represents the population of the town, this is the initial population of the town. So initially, this town has 25,000 people, and growth rate is 2.5% because 1 plus R equals 1.025. The R itself is 0.025, which is 2.5%. So this is not part of this question, but this is a good opportunity to mention that this number inside represents 1 plus R actually. So this number bigger than 0, that means your R is positive, it's growing. So this town's population grows at 2.5% per year. Okay, move on to the next one. The price Y of a computer memory. So Y represents the computer memory price. So it's in dollar. So the output is the price dollar. In X years, X is input on the right-hand side. So X is time in years. That means what? The price output depends on input, right? We learned that already. Output depends on input. That means computer depend on the time in years. Since there's a D, which is a linear model, look at this format, initial value, growth rate times input. Initial value, growth rate times input. So growth rate is negative, that means it's declining. So this computer memory price will decline $25 per year because the X measured in years. So, but we only need to answer this question, what is the initial value? So we know in this general format, it's a number standing alone by itself as initial value. The number with the input is growth rate. So you're looking at this number. So it's the initial value is $300. Again, this is the representative price. This models computer memory price. So this is the price. Okay, now next one. We want to be able to determine model types. In other words, your answer going to be one of these three, either linear, exponential, or neither of these two. Okay. First of all, we are given graph. This whole thing is about identify what kind of model you have by looking at a graph. So this graph above is exponential model. How do we know? First, exponential model has to be curved. It's not straight line. Straight line is linear. The two requirement being a exponential model. First, a smooth curve. Secondly, it doesn't matter going down, going up. Okay. Secondly, it goes in one direction. It cannot make a turn. If it goes up forever. If it goes down forever. Cannot just make a turn in the middle. So smooth one direction. So you get exponential model. Because we have exponential model here. No matter how you change P0 and R, this Y, this X never change because input and output, this variable never change. If you graph this, it's always a smooth curve, either going up or going down, depending on R positive or negative. But either way, it's an exponential model. They call it the exponential curve. It doesn't matter going down, going up, but it will be a smooth one in one direction. Now, how about this one? Apparently, smooth one direction, but whenever we read a graph, we always read it from left to the right. That's like a convention by default. From left to the right, this graph going down, smooth. So this is exponential. Only difference between this one and the previous one is that R is negative this time. It's decreasing. So if you look at this two axes, horizontal one is time, vertical one is temperature. Remember, the horizontal one represents the input, independent variable. The vertical one represents the output, dependent on variable. Output depend on input, right? Temperature divided by dependent on the time. So as time goes by, time from left to right increase, that means going by, and the temperature decrease. So that's the meaning of this curve. Another one, let's do this one by one from left to the right. This one, this is a graph. Apparently, this is a line. This is a linear model. If you look at this word, this is the remainder. This is a line. Linear. That's the reason we call it linear, because graph is a line of this model, linear model. And the P0 plus dx. This is a straight line. Input, output, two numbers. The number in front of x represents the slope of this line, actually. Positive slope going down, negative slope going positive slope going up, negative slope going down. And either way is a linear. Now the one to the right is neither, not linear, not exponential. Apparently, this is not a line. Secondly, it's a curve. It is smooth, but it's not in one direction. So it's not exponential either. Now, here's the thing. Maybe this is one of the most difficult one in this model type assignment of your homework. Basically, this is more like in algebra, pre-algebra, but yeah, this is one of those questions in your homework. Let's look at this. Now we need to choose from increasing, decreasing, or neither. How do we tell that? Say when we learn the slope of a line, say we learn that positive slope represents increasing from left to the right, the graph is increasing. Negative slope means from left to the right, the graph is decreasing. Graph decreasing, increasing represent output, okay? When input increases, if graph increasing, that means output increase too. If graph decrease, that means the output decrease when input increases. Input always increase from left to the right. Say how do we tell for this particular one? That's why they ask you to calculate the rate of change and also calculate the ratio of rates, because these two numbers, these two columns of numbers will tell you whether increase or decrease, whether it is the exponential model or linear model. They tell you everything basically. And the first column is just for you to calculate the slope. This is 0.1, 0.2. Another point. Every 2 points you can use to calculate slope. And we learn the slope formula, right? Given 2 points, x1, y1, x2, y2. Suppose these 2 points. How do we calculate slope? Slope is also called rate of change. They're the same thing, okay? Slope. And you just use y minus y. Doesn't matter which one minus which one, as long as you do it in the same order when you use x, okay? y1 minus y2, top one minus bottom one, then x, top one minus bottom one, as long as you do it in a consistent way. So they already did the calculation. We don't have to redo that. And you can see these slopes they ask us whether increasing, decreasing. They didn't ask a linear or exponential. So we already know that positive slope means increase. Look at the slope, they're all negative. So it's very easy to choose. This one is decreasing. just by looking at the slope. After you calculate the slope, maybe I demonstrate how to calculate the first one. So using the first 2 points, and this is tell you from point 2 to point 1 using these 2 points. It doesn't matter when they say from point 2 to point 1 or from point 1 to point 2, because if you connect 2 points, no matter which one is first point and which one is second point, is the same line. Same line will have same slope. It doesn't matter the order in terms of calculating slope. So I just use the first number minus second one, but you have to use y minus y. So 100 minus 55. First one, 100 minus 55 over x is 0 minus 4. So basically it's negative 45 over positive 45 over negative 4. So let's do division. Positive divided by negative, still negative. So we don't have to input negative sign because we already know the result is negative. So that's 45 divided by 4. 11.25. So apparently they rounded to the first decimal digit, negative 11.3. So that's how they calculate slope. Since the slope is negative, it's decreasing. Okay, now let's look at the next one. Next one, very similar problem with just different set of numbers. Doesn't matter, we just do calculation just one more time. But after you do this calculation, what these numbers tell us, that's more important because everybody can do calculation using the 2 points, calculate the first rate of change, using second and third point, calculate the second one, third and fourth, calculate the third rate, and fourth and fifth, calculate the fourth rate, and so on. You calculate all of the rates. And this time, apparently increasing because the slope is positive, but they didn't ask us. They asked us if it is linear, exponential, or neither. How do we know? First, if you have a line which is linear, right? One line can only have one slope. Is that right, everyone? One line can only have one slope. Look at this. This point apparently is not on the same line because they have different slopes. Apparently they are not on the same line. That means it's not a line. If they're all on the same line, you can only have same slope because one line can only have one slope. Since the slope different, this only tell you this is non-linear. It has not tell you that this is exponential yet. It just tell you not linear. But how do you know if exponential or not? Look at this number. This number has to be a constant number. That means it cannot change. Constant ratio of rates. And this will give you the exponential model. So this is exponential model. And I summarize this whole thing and put it on the second page. So basically how to determine whether a graph increase or decrease, linear or exponential or neither, using the following as a reference. Again, you need this point to calculate slope. After you have slope, I mean rate of change, that's the same thing. You do ratio. In this one divided by this one, that's the first ratio. This one divided by that, the second one, and so on. And if this slope is a constant number, that's linear, no matter positive, negative, as long as it doesn't change, it's linear. In this case, it's linear. If it is not the same, that means it's not linear. Then you have to look at this. If this is a constant, well, there's a problem here actually. The previous on the previous page, I said it's constant, but it has to be non-zero. Let me make adjustment here. Non-zero, it's not non-zero. Not one. Has to be a number, not one, but it's constant, non-change. If one, the ratio is the same, actually you won't have one. You never have one. If you have one, that's not exponential. Actually, that's not exponential. Exponential have to be have to be not one. That's why I add this not one. So this one, let's look at this. This is my explanation here. You calculate the slope first, then you calculate the ratio. I just demonstrate how to get this ratio here. This rate from here to here. Then you can use the sign of the rate of change to determine whether it's increasing, decreasing. Positive, increasing, negative, decreasing. in terms of linear or not, if the rate of change is constant, it's linear. So constant linear, we already mentioned that, right? And how do you know it's exponential or not? It is exponential if the ratio, the ratio of rate is constant and it's not equal to 1. So just I already put it in here. Or you can also tell by go through this flow chart, but it's not very clear. But this is on your homework page. Actually, if you did the homework, you get feedback, you get this part. But this part is good enough. As long as it's constant, it's not 1, it's exponential. If we don't have that, that's neither. So for this one is neither, because this not this is linear already. For example, if this one is not the same and this is 1, and that is neither. Okay, now next one. During a strenuous workout, a tennis player burns 8 grams of carbohydrates in 5 minutes and 20.8 grams in 30 minutes. How long will it take for you to burn 30.4 grams of carbs? And how many calories do you burn in 23 minutes? Now, before, I remember when we did the lecture in this part, and basically we set up a linear model, and then using that linear model to answer these 2 questions. Now, and there's a new way to answer these questions, as long as they don't ask you to create a linear model, and you don't have to create a linear model to answer this kind of problem. We assume this linear model. The reason is like this, like proportion. The more time you exercise, the more calories you burn, right? So usually this is the proportion. Proportion itself is linear between input and output, linear relation. That's why we can use proportion to solve this. Let me show you how to solve it using proportion. You can save like 80% of work. Now all you need is to write this number. So we have 2 sets of numbers. 5 minutes time is independent one, and calorie is dependent, because how much calorie you burn depends on how much time you exercise, right? So that's why time is independent variable and calorie depend on it. So calorie is output. Input always first, then output. 5 minutes, 8 grams. Then another one is, what is that? 30 minutes, 20.8 grams. So you're given these 2 points. Now here's the thing. And in setting up proportion, you just need 2 pairs of numbers. Try to recall the format of proportion, right? The format of proportion. You need 2 pairs of this. And for this particular problem, you only need 1 pair. You can use any of these 2, either of these 2. Doesn't make a difference. The result will be the same. So I'm going to use the first one, because first one looks simpler in terms of numbers. So 5 minutes, you burn 8 grams. Now this 2 is given, okay? These 2 are related, just using a pair of numbers to set up a ratio. Now, the way we set up proportion inside is very simple. All you need is to make sure the quantity with the same unit is on the same side. For example, I put minute on the top side and gram on the bottom side, and the other side, I do the same thing to answer the question. Since we need a time is on the top, that's our x. And the bottom is gram is 30.4 grams. See, same unit on the same side, both on the bottom, time both on the top. That's how a proportion works, okay? Now, all we need to solve this. So x equals cross multiplication, 5 times 30.4 divided by 8. And let's do that. 5 times 30.4 divided by 8, 19 minutes. Yeah, 19 minutes. And let's say next one. The next question is question 1 and question 2. So the question 1, now question 2. Question 2 is we solved it the exact same way. You can also still use this for 5 minutes, 8 grams. This time we are given minutes, so put minutes on the top. We are looking for grams, x is on the bottom. Solve that. X equals 23 times 8 over 5. That's how simple it is. 23 times 8 divided by 5. 36.8 grams. 36.8 grams. And we just solve it. Okay. If they ask you the model, just in case they ask you the model, usually they expect that, look at this model, this is the actual for this problem, it's not part of this problem. Look at the original format of linear model, dn. You need a slope, you need initial value. Initial value has to be the point on the y-axis. Apparently, the 2 points are not on the y-axis because on the y-axis input is 0. X is 0, it's not 0. They expect your initial value is on the y-axis for this type of problem. How do you do that? First, you need to find the rate of change. Okay, the rate of change, and by using these two numbers. So I'm going to do that quickly. And 20.8 minus 8, y minus y, x minus x, right? 3 minus 5. Let's do that. 12, this 12.8. Let's just do the calculation. 20.8 minus 8 equals 12.8 divided by -2. Divided by 2, we get 6.4 negative equals, is that right? 20.8, yeah, negative 6.4. And oh, apparently I'm wrong. Cannot be negative because the longer time you exercise, the more calorie you burn. That's how I detect something wrong. This is 13, it's not 3, apparently. So we do the calculation. 12.8 on top divided by 13 minus 5 is 8. 1.6. This makes more sense. So it has to make sense to be right. 1.6. On the top is gram, on the bottom is a minute. So this tells you for every minute you burn 1.6 grams of calorie. So after you have this, put it in here. That's your growth. That's your rate of change. So Pn equals P0 plus 1.6 n. Now you need to find out this P0. P0. So how do you find that? This is like an equation solving for P0. In order to have an answer for a single equation, you have to only have one unknown, which is this. That means we have to know the other two. Do we have? Yes. This is input, this is output. Input, output, input, output. Just put one of these pairs in here. We solve for P0. Again, you can use either one because either one is on the same line. This is the line. So output is 8. P0 plus 1.6. Input is 5. 5 times 1.6 happen to be 8. So cancel. P0 equal to 0. So if P0 equals 0, this is gone. So your model is Pn equals Dn. D we already calculated is 1.6. So Pn equals 1.6n. Yeah, that's it. That's our model. If they ask you model, this is the model. But if they didn't ask us that, that's all we need to do. Okay, next one. An airplane is cruising at 300 miles per hour to its destination 2,400 miles away. Create a model representing the relationship between the time in hours and the number of miles remaining to destination. So if you are flying towards that destination, as time goes by, you're getting closer to the destination. Is that right? That's common sense. So that means the distance to destination getting shorter over the time, right? So your output is distance, time is input. So let's say they didn't say what variable we use. So let's just use this Pn as output. So how do we know what model is this? before you create a model, you have to know whether it's linear or exponential, right? Otherwise, you could be totally wrong in the very beginning. So how do we know? During the lecture of linear model and exponential model, we mentioned the characteristics of these two models. And for linear model, the change has to be a constant number. Look at this, 300 miles per hour. If this is an airplane, try to imagine that. Yeah, try to imagine that this is an airplane. This is airplane, right? This is your destination. Over the time, your distance getting shorter, shorter, and shorter. How you get shorter? This is the speed. Every hour, you get shortened by the distance gets shortened by 300 miles. Another hour, another 300 miles shortened, right? So the change is constant. Whenever the amount of change is constant, it's linear. Like a Marco guy's antique bottle increased by 32 bottles per year, right? Because he bought 32 bottles per year. The change is constant. If the change is constant percentage, that's exponential model. If the change is constant number, it is a linear model. Actually, it's very easy to tell if you pay attention to that part. So this is a linear model. So we use a linear model prototype, right? This is a linear model. All we need is figure out the initial value and the rate of change, how fast things change. Initial value apparently at the moment it is 2,400 miles away. That's the initial value because the output is distance. This distance initial both a p, right? This sort are the same thing, just the initial one and the final one. So Pn equal initial 2,400. Now D is growth rate. If it is increasing, it's a positive number. If it is decreasing, it's negative number. Since this speed will decrease the distance because getting shorter and shorter over the time, this has to be negative. Time never negative, right? So minus 300 miles per hour actually makes sense. Every hour is shortened by 300 total distance. So if this one, this becomes 2,100 after 1 hour, right? Because you minus 300. And this is called the model. For model, you have to have input on the right-hand side, output on the left-hand side. You cannot have number in here to be called a model. Input, output, that's a model. Okay, next one. The price of a particular model car is $27,350 today, and its price rises at 3% per year, constant percentage change. This just tells us this is a exponential model. How easy is that? Create a model representing the relationship between the price of car, which is output, in dollars, and time in years. That means time is our input because price depends on time. Time never depends on the price, right? Okay, so Pn, general form of exponential model equals P0, 1 plus R to the power of n. All we need is determine initial value and growth rate. So Pn initial value apparently 27,350. 1 plus R, since it rises, it's positive, over time it will increase 3% to the power of n. And put this together because this two can be added together. It's 27,350. Usually your homework requires you to put them together, even though our original formula has two parts. 1.03 to the power of n. This is called exponential model. Again, input, output. Linear model, input, output. You always have input, output. You just need to determine the initial value and the growth rate. So put them together to become model. And look at the next one. A Greyhound bus leaves its station in Washington, D.C. It covered a total distance of 180 kilometers in 3 hours and 300 kilometers in 5 hours. Create a linear model representing the relationship between the bus distance from the station in kilometers and time in hours. Greyhound bus leaves station in Washington. Yeah, apparently, if you imagine this is a station in DC, okay, right here, leave it, right? Go to somewhere else. And basically, it just tell us 180 grams in 180 kilometers in 3 hours, 300 in 5 hours, and just 2 data points, right? Like after 3 hours, this is 180 miles. 5 hours, 300 miles, 300 kilometers, right? Something like that. We need to create a linear model. They already tell us linear model. So we're going to have Pn equals P0 plus Dn. All we need to determine is P0 and D again. N is input, Pn output never change. So how do we determine that? As long as you know the linear model has a straight line as a graph, right? A line has a slope. Slope is equivalent to D, the growth rate, the common difference. How do we calculate slope for a line? We need 2 points, right? Do we have 2 points? That's why we are given these 2 pairs of numbers. 3 hours, 180 kilograms, 5 hours, 300 kilograms. We can calculate the slope. When you write the 2 points, make sure you write it as input-output pair, input always first. So 3 hours, 180 kilometers. Because how far you can travel depends on how many hours you drive it, right? So miles is output, time is input. Now 5 hours, and that is 300. So we use our famous formula, y minus y, doesn't matter which one minus which, as long as you do it in a consistent way. So top minus bottom, top minus bottom. And if we do that, that's 120 negative, and this negative 2, negative divided by negative is positive. So 60 kilometers per hour, that's our speed, that's our slope. So put it in here, 60. So Pn equals P0 plus 60N. Now we still need to find the P0. How do we find that? Actually, I did that on the previous slides, right? When we calculate that calories and minutes, the same thing. You can only have one unknown. You have to have the other two to calculate it. The other two just input, output. Again, input, output, input, output. You can use either one. So this time we're going to use second one. Just have a change. Actually, there's no difference. It's just for that sake, no difference. I use different one. Last time I used the first one, right? Let's use the second one. So output is 300 equals P0 plus 60. Input is 5 hours. 5 times 6, 300. That's the same canceled. P0 equals 0. Since it's 0, we have Pn equals 60N. That's our final answer. This is the model, linear model. And since both examples have P0 equals 0, and people tend to think P0 is always 0. It's not true. It's not true. Okay, it's not true. I just want to mention that because all of our homework problem designed in this way, that will result in P0 equals 0, but that doesn't mean P0 is always 0. Okay, now move on to the next type of problems. Look at the requirement. We only need to identify the financial application represented. That means we don't need to do any calculation. We just need to tell which financial application is going to be applied here. So Jackson Moving Company borrowed $9,400 for 125 days and paid $244.79 in interest. Find the rate of interest on the loan. So for financial applications, we only have basically 3 types, 4 different ones, but 3 types. First, you may have simple interest account. Second, you may have this compound interest account. Third one, you may have annuity account. That's 3 types. Why I said we could have 4 different applications, because in annuity type, you could have the future of annuity account, the future value of annuity account, or the present value of annuity account. That's why we have 4 kind of problem, but we only have 3 different types. This one, the major difference between simple interest and the rest is very easy to tell, because no matter you have compound interest account or annuity account, both involve compounding. Both involve compounding. In other words, they have to measure how often your account is compounded, like compounded monthly, compounded yearly, compounded in the semi-annually, and such. If they don't mention that, that means by default it's simple interest. So this one is simple interest. because it didn't mention anything about compounding. That's how easy to tell. Simple interest. So you just select something close to this. If this is not exactly the wording of it, simple something close to this in your drop-down options. Now, next one, a mother invests 9,000 in a bank account at the time of her daughter's birth. The interest is compounded quarterly at a rate of 7%. What will be the value of the daughter's account on her 20th birthday, assuming no other deposits or withdrawals? This is a critical information, actually. What this means is that this 9,000 is one-time deposit. And that's a major difference between a regular compounding account versus annuity account. In annuity account, no matter you have future value of annuity or present value of annuity, both involve repeating deposit or repeating withdrawals. Regular deposit or regular withdrawals. It's not one time. And this one time and compounding is just regular compound interest account. I hope I made it clear enough. Compound interest account, again, depend on the wording and choose the closest one from drop-down menu. Last one on this page. Southwest Dry Cleaners believes that it will need new equipment in 7 years. The equipment will cost $26,000. Apparently, this is the amount they needed in the future in 7 years, right? That's a future value. What lump sum should be invested today at 10% compounded annually to yield 26,000? In other words, 26,000 is a future value, but it's also compounding because we're told that compounding. But this is 20. They ask us what lump sum. That means one-time deposit, right? One-time deposit is compounding. That's compound interest application, just like the last one. Again, it doesn't involve multiple repeating deposit or withdrawals, right? So that means it could be an annuity if that's the case, but this one is not. One lump sum deposit and compounding. That's regular compound interest application, just like the previous one. They're the same thing. Okay, we have a last page, and look like 3 questions. At 8:30, we still same type of problem to identify applications. At 8:30, Michelle starts an IRA to save for retirement by depositing $100 at the end of each month. That's critical information. Fixed amount, periodic deposit, right? That's annuity. If she can get 6% compounded annually on her IRA, how much will she have when she retires 30 years after at age 65? Apparently, we are looking for future value. How much will she have, right? So this annuity, we ask her to find the future value. So what do you say? Future value of annuity. That cannot be clearer than that. So future value of annuity. That's it. That's very clear. Next one. Upon retirement, Greta wants to be able to withdraw 12,500 at the end of each month. Fixed amount, regular withdrawal at each 6 months for 7 years. Assume that money can be deposited, this is just terms, 8% per year, compounded semi-annually. What amount does Greta need to achieve her retirement goal? We don't care about that because we don't do any calculation. We just need to identify financial application. Again, this repeating withdrawal, and this is the withdrawal amount. Now, we mentioned in the lecture video, actually, how you identify present value of annuity problem. Basically, you just have 2 types of problem. And first type, no matter which type, actually, you have to have certain amount in the account to sustain your periodic withdrawal. So 2 types are you withdraw money periodically from an account, or you pay monthly mortgage. These two types involve the present value of annuity. Present value annuity, all it means is that you have some lump sum of money in the account in the beginning before you do periodic withdrawal. So if you don't have money, there's no way you can make that periodic withdrawal, right? So mortgage is exactly the same thing. Mortgage is instead of your own money in the retirement account, you have total debt, but after each payment, you reduce your debt by a little bit, fixed amount every month, right? Retirement account is the same thing. You have a certain money in your account when you start withdraw, and after each withdrawal, you reduce your total money in the account. The nature is exactly the same for these two events: mortgage monthly payment, monthly withdrawal from your retirement account, no difference. That's why both involve the present of annuity formula. So this is the present value of an annuity. Okay. Now, last one. This is a long one. 3 questions looks like. Yeah, 3. 1, 2, 3. Okay. You take out a home loan for $205,000. The interest on this loan is fixed at 6.5% compounded monthly for 30 years. And how much is your required monthly mortgage payment? So monthly withdrawal, and if you do monthly withdrawal, your compounding will be also monthly. If you do quarterly withdrawal, and your compounding period is also quarterly. They are always the same. This is also same for the mortgage. Okay, how much is your required monthly mortgage payment? We just mentioned from previous exercise that mortgage payment and present value are the same thing. So we just use the same formula. I'm going to put it in here, say to save some room. Present value of annuity equals withdrawal amount or mortgage payment monthly payment amount. 1 minus parentheses 1 plus R over K to the power of negative NK over R over K. Okay. Now let's answer the first question. Monthly payment, we calculate D, right? So the first question, and present value is total debt currently at the very beginning equals D times 1 minus parentheses 1 plus interest rate is 6.5% over 12 because we compounded monthly, negative, and this is 30 years, and K is 12, and over 6.5% over 12. So I'm going to do this whole thing on the calculator, and then we write down the number. So let's look at it. 1 minus parentheses 1 plus 0.065 over 12, close parentheses, and to the power of negative 360. Yeah, equals. And this number is always a positive number below 1. So divide by parentheses 0.065 over 12, close it, equals, yeah, this is the number we're going to copy. So we got 205,000 on the left-hand side equals D times this number, 158.2108195. Copy the whole thing. And now we just do a simple division and put D in here. 205,000. Yeah, divide by this number, 158.2108195 equals. So we got 1,295.74. So this is the monthly payment. Now, round to the nearest whole dollar. That'll be 12.96. So put it in here, 12.96. I always look at the requirement. Next one, use the whole dollar amount calculate as a monthly mortgage payment over the entire period. That means total payment, out-of-pocket payment, and that's relatively easy because we pay $12.96 is the whole dollar amount a month, the 12 months in a year, and we have 30 years. So let's do that. $12.96 times 12 times 30 equals, so we got 466,560, and that is total amount. Now, number 3, what is the total amount of interest? So interest is very easy to do. We use total amount you paid, which is this number, subtract your total amount of the debt in the beginning, right? So that's a 466, 560 minus 205,000. So let's I still have this on the screen. So minus 205,000, 261,560. So you pay the interest 261,000, a little bit more than that. You borrow 205, you pay the interest 261. So that's significant. That's all for this exercise section. Bye, everyone.